Hello, I'm Sri from CBTU. CBTU presents a course on TensorFlow, an open source machine learning framework. Agenda for this session: what is Tensor, TensorFlow, install Python, install TensorFlow with Python's pip package manager and Docker images, install Jupyter Notebook with pip and Anaconda, run notebook example with local runtime and in Google Collaboratory notebook file. TensorFlow is the backbone of machine learning. TensorFlow is an open source software library for data flow programming across a range of tasks used for machine learning applications such as neural networks. It's used for both research and production at Google. Tensors are nothing but multidimensional data arrays. The name TensorFlow derives from the operations neural networks perform on tensors. In 2011, Google brand built this belief as a proprietary machine learning system based on deep learning neural networks, which became TensorFlow. It can run on multiple CPUs and GPUs. It's available on 64-bit Linux, macOS, Windows, and mobile computing platforms. TensorFlow architecture is flexible and allows easy deployment of computation across a variety of platforms and from desktops to cluster of servers to mobile and edge devices. These companies are using TensorFlow. TensorFlow is tested and supported on these operating systems. We can install TensorFlow with Python's pip package manager and from Docker images. We can run TensorFlow in Google Collaboratory, which is easy way to learn and use TensorFlow. Let us build a TensorFlow pip package from source and install it on Windows. We need to install Python and TensorFlow package dependencies. We have tested TensorFlow with Python 3.5 without any issues. We ran into trouble while installing it Python 3.7. This is Python download page for Windows. Let us download 3.54. While it downloads, let us go back to presentation. Download and install Python. We need Python 3.5.4 64-bit installer. Let us download. Let us install. Install to the default path. And let us add Python 3.5 to path. Install. Python for Windows is installed. Close. Let us open another window. Yes, Python 3.5.4 is installed. So installing the TensorFlow, we have these steps. Let us verify pip package manager. Pip space list gives out the list of all the packages that are installed. We have Jupyter that is installed previously, NumPy, TensorFlow, Wheel. Okay. Another prerequisite is install the Microsoft Visual C++ 2015 Redistributable Update 3. So this we have installed and create an virtual environment. This is recommended. Let us create. So there is some issue with compatibility. We cannot create virtual environment. Let us try this as well. Let us upgrade pip. Now it gives error. Let us list packages. Gives error. Let us deactivate virtual environment. So we have installed all these dependencies. Once again, we'll update. Requirement already satisfied. Keras applications is installed. Keras preprocessing is also installed. Let us try pip install TensorFlow. Let us upgrade. Is done. Let us see the packages. TensorFlow 1.12.0, this is the latest. TensorFlow 1.12 is latest. These are the other prerequisites which are installed. We need to install Visual C++, Build Tools 2015, Redistributable Update 3. This one we have already installed. We have installed TensorFlow with pip install. Let us verify the install. Is having some compatibility issues. Okay, let us run MLab. This sample application let us run on our TensorFlow. Copy. Let us get into Python shell. Run. We will explain each step while running this in Google Collaboratory online notebook file. Evaluate. Done. Let us run the same example in Google Collaboratory. We can connect to the local runtime as well with Jupyter Notebook running on your local system. Right now we are connecting to the hosted runtime. This is a great way to practice and understand TensorFlow. We are connected to the Google Collaboratory hosted runtime environment. The code we have run here, import TensorFlow as TF. This is to import TensorFlow library into our program. Let us run. This is running online. Then load and prepare MNIST dataset. And next step, MNIST equals tf.keras.datasets.mnist. This is to load and prepare the MNIST dataset. MNIST databases of handwritten digits has a training set of 60,000 examples and a test set of 10,000 examples. It's a subset of larger set available from NIST. It's a good database for the people who want to try learning techniques and pattern recognition methods on real-world data while spending minimal efforts on preprocessing and formatting. These are the files available on this site. Let us load. It's downloading MNIST data from this location. This is downloaded. Next is build tf.keras model by stacking layers. Let us run this. It's run. Now the next step is train and evaluate model. Yeah, it is done. This is running ML example online, Google Collaboratory online notebook file. We can connect to the local runtime as well. For this, we need to have a Jupyter notebook on our local system. Let us see the instructions. We can connect to the local runtime using Jupyter. Let us install Jupyter. We can install Jupyter using Anaconda or with pip. Anaconda is recommended as it takes care of all the dependencies. Installing with the pip. Let us install Jupyter. Let us exit Python shell. Jupyter installed. Let us run. We see Jupyter in pip package list as well. Okay. Let us test. This command will start the notebook server from the command line. Notebook is accessed at port 8888. It's opened in Internet Explorer. Let us try to open in Firefox. Yeah, it opened here as well. For opening in the browser, we have used this token. This is the token for authentication. We can start Jupyter Notebook without browser as well. Let us close this. Use the flag no browser. To log into the browser, use this URL, paste it into the browser. It opens in the browser. Let us try connecting to the local runtime. Default port is 8888. Connect. It's unable to connect, but having issues connecting to the local runtime. Okay. Similarly, we can install TensorFlow from Docker images. In another session, we'll take this. We have these images in the Docker Hub repository. You explore this further based on your need. In the next session, we'll be using Amazon SageMaker, which is based on TensorFlow. This is TensorFlow on AWS. This is Amazon SageMaker. Please watch Amazon SageMaker for more information. Back to our presentation. These are some of the screenshots which are captured. Python 3.7 is installed and this is the version. Virtual env is not recognized. We need to install. We use the pip install virtual environment. It is installed and the version is this. This is installation of Microsoft VC++ 2015 Redistributable Update 3. This is virtual environment setup. Creating a virtual environment using Python interpreter and making /venv directory to hold it. Activate the virtual environment. And this pip list shows the packages installed within the virtual environment. And exit this or deactivate this when you are done with the TensorFlow. Latest version is TensorFlow 1.12.0. This is the command to install TensorFlow with pip. Pip install TensorFlow. Installing TensorFlow. It's asking us to upgrade pip version. Right now it is 10.0.1 and 18.1 is available. So this is the command to upgrade pip. So it's upgraded and the latest version is 18.1. Installing TensorFlow pip packages. This is the Windows package, wheel file. Installing dependencies. Installing dependencies again. Now installing TensorFlow. It's installed and the list of packages. TensorFlow here. This is testing TensorFlow. We got into some compilation error. This is TensorFlow website. This is the sample script which we have used. MNIST database of handwritten digits which we have used in our ML example. We entered into Python shell and pasted the code here. This is running ML example in Google Collaboratory Notebook, hosted runtime. This is running ML example online. We can connect Google Collaboratory to connect local runtime using Jupyter. For connecting to the local runtime, we need to install Jupyter on local machine by pip or anaconda. Install and enable Jupyter HTTP or AWS Jupyter extension. Start Jupyter Notebook server and authenticate with token and connect to the local runtime. This is Jupyter install web page. Prerequisite for installing Jupyter Notebook is Python, and we can install Jupyter using Anaconda distribution or with Python's pip package manager. This is Anaconda page. Google Colab local runtime settings. Installing Jupyter with pip. Enabling this extension. Opening Jupyter Notebook in the browser. Opening Jupyter Notebook in Firefox. It needs a password or the token. And also we need to enable network WebSocket, allow insecure from HTTPS. Default is false. When you double click, it changes value to true. This is required for notebook to run in Firefox. Running in Firefox. This is a brief session about TensorFlow. We'll be covering about TensorFlow and Jupyter Notebooks in AWS Machine Learning session. Thanks for watching.